Welcome to another podcast. In this episode, we're going to be taking a look at another example involving ratio test. This one's going to end up with a tricky limit, and that's the main reason I wanted to address it in this video. So let's just dive right in and see what we can do. The general term of the series here is n raised to the n over n factorial. And so if I apply the ratio test here, I would look at the limit as n goes to infinity of the absolute value of start with an plus 1. So an plus 1, all of the n's would turn into n plus 1's. So this would be an plus 1 times 1 over an, so the reciprocal of the general term. This is 1 over an. Okay. Next is the cancellation step. So if I'm looking to try to cancel these, then all I can do right now is n factorial and n plus 1 factorial cancel, leaving an n plus 1. And then if I look here, the n plus 1 to the n plus 1, I can cancel I can cancel one copy of those with this, leaving n plus 1 raised to the n. So I can cancel one copy with the n plus 1 that was produced there. To clean this up, I have the limit as n goes to infinity of, in the top is n plus 1 raised to the n, and in the denominator is n raised to the n. So this ends up being the limit as n goes to infinity of, the best way to write this is quantity n plus 1 over n, since they're both raised to the n power. And then to make one more adjustment and write this as 1 plus 1 over n to the n. And it turns out that this limit is an incredibly important limit in mathematics. It's one of those that you may or may not remember. It is a positive value here, so I can drop the absolute values. And so this limit that we're looking at for this problem, it turns out to be the value e. So it's just something that you should probably commit to memory at this point. This is the value e, and in general, if you look at the limit as n goes to infinity of 1 plus r over n to the n, this limit is e raised to the r. And so this limit is an incredibly important limit in a variety of ways. It has financial implications, so you look at financial models. This model is continuous, what's called continuous compounding. So if you look at the compound interest formula from a finance class, this limit appears there. It should have been a limit you talked about in Cal 1, but just in case you didn't, I wanted to go over it now. And the point is, if you look at this limit, e is approximately 2.718, and for our purposes, all we care about is the fact that that limit is greater than 1. And so because that limit is greater than 1, we know that this thing is going to diverge. So this diverges by the ratio test. We came up with a limit, and the limit has to be less than 1 for convergence, and because the limit's greater than 1, we know that this diverges. That says, basically, that n over n grows faster than n factorial. Those terms are getting way too big, way too quick, and so this thing isn't going to converge at all. And so a couple of interesting things in here. We looked at the limit of how exponential is defined as the limit of these terms. We also had a couple of interesting cancellations in this problem. So this is a good way to round out our discussion of ratio tests. We have 3 videos on ratio tests now, so there's something there for everybody. Depending on kind of how you can get into it, you should be able to find, you should be able to gain a little bit of traction with the first video, sort of a simpler example, and the next 2 examples are a little bit harder to sort of teach you what to do if you're faced with problems that involve A, factorials, and B, powers, those are both prime candidates for applying ratio test. All right, thank you for watching.